So I saw the movie last night at midnight. Should I tell everybody that Tony Stark dies at the end? Oh, sorry. Hi everybody. My name is Bill Klos. We're talking to you today about how wonderful airport operations mimics architecture that we have for cloud operations. Who's been to an airport? Who loves going to the airport? I got a couple sadistic people in here along with me. So I'll go through and I'm going to try to establish some sort of geek connection with you guys. This airport is Toronto. Anybody know what Toronto is famous for? Airport? YYZ because? Thank you. All right. Gold points for you guys. All right, so introduction, Charles de Gaulle here. We'll just go through a few of these as we go through. My name is Bill Klos. I work for Centric Consulting. I'm a senior architect here locally in Columbus. And I work with the cloud practice, and one of the things I do with cloud practice is try to build things that are somewhat scalable. Sometimes I'm successful, sometimes I'm not. So there's my company. That's the requirement that I'm have to give here, and you will not see that again, except for my shirt. My day job, as I mentioned, when I get up every morning, this is what I want to do. When I graduated from high school, this was the exact thing I wanted to be an architect. I wanted to be an architect and build the coolest buildings I could possibly build, make a statement, change the planet, all that kind of good stuff. When I found out my first year that I didn't get a chance to draw, I actually had to build models and cut out things and glue things together and study trees and that kind of stuff. I decided it wasn't for me, and I decided to switch over to computer stuff and took a different kind of architecture road. So now I get to make sure I don't do problems like these. So this is what I spend my day trying not to do, is come up with these kind of brilliant designs. Now my hobby is some of the travel that I do, and we are a no travel company, but I choose to travel. My kids are older now, so I choose to go to airports, and not to go to the airport specifically, but for work I go to airports, and these are the ones I've collected over the last several years. And I just kind of memorize the code, so when I'm talking to somebody else, it's like, oh, where are you going? I'm going to NRT for the week, and I'll be back next week, but then I got to go to SIN after that, and then YYZ for that, and then CMH. So it's all that kind of good stuff. It's one of those really, if you're really nerdy in the airports, you start talking in airport codes. So this gives me time to essentially contemplate my life. Contemplate my life, look out the window and observe. Have you ever watched the orchestration that they have outside with all the carts and the guys with the earphones and the wavy things and so forth? You would think if I'd spend more time in airports, I'd know what those are actually called. And I stand in line. I stand in line to check in. I stand in line at TSA security. I stand in line to get to the gate. This is actually the most important line to stand in because you're jockeying for position, right? And then my baggage stands in line too. So all these lines are going on, and I even have time left over to complain. However, 80% of all flights are on time. Of the 18.8% of that 20%, the reasons they're not on time are for reasons like this: aviation system problems, so software on the plane, late aircraft, which is usually the case, maintenance crew, weather, and security. Not one of those single times was I the cause of that because I could not get through the process quick enough. Now, I will say that there are times where planes wait for people coming from other connections, and I think Southwest is pretty good about this. Good to a fault, where they'll wait for up to 45 minutes, I've heard, for a connecting plane to get two or three passengers off of it to get onto your flight. So in that case, it would be waiting on me, but not because of the process. Now, from a baggage perspective, which is also waiting in line, this is what people typically think. Who were my children of the 70s that were old enough to watch TV then? Do you guys remember the Samsonite commercial with the gorilla? Yeah. That's essentially what you're thinking is going on behind the scenes. But at London's Heathrow, LHR, this is what it actually looks like behind the scenes. It looks very much like an Amazon warehouse. So they're moving your bags through here in a very systematic manner, very organized, very cool. And they have 145,200 pieces per day that they deal with. Of those, they have 416 mishaps, which works out to be about 0.287%. Or 2.87 mishaps out of 1,000 bags handled. So it's pretty efficient. So while our experiences at airports contain stories of horror, and using this as a sample size, they all work pretty much the same. You stand in line here, you stand in line there, you stand in line here, and you get to where you're going, for the most part, without too much fuss and muss. So I wondered, airports must be doing something right. So you've got all these disparate, disconnected systems out here that need to talk to each other, need to work, very much like cloud stuff that I deal with. So I had an idea. And this does not quite have the same impact as this, but that's the actual idea that I have. And it's like, what lessons can I learn from airport operations and use those to put into my architecture designs for applications? I was telling my son about it. It's like, hey, you see how the way that guy's doing the luggage processing out there on the plane, how they're going to get it off, and where they put the priority luggage on the plane, and where they put the other, low-end luggage on the plane, I guess. So I could probably do that with airport system design or system design. And he said, pretty much, you're a nerd. So, 7 patterns. Airport queue patterns that I've not really come up with, but these are the things I typically use in my designs. So on a typical airport day, you get your boarding pass, you check your bag, if you're going to check your bag. You get routed to security checkpoint, you get your ID out, and you get that checked. You get scanned, you get some food if you're so inclined. Jockey for boarding position, again, the most important piece. You line up for takeoff in the plane. You line up for landing on the approach for coming back in. You jockey for deplaning, which is also very important. And then you retrieve your bag. A lot of lines to stand in, and that's if everything goes right. This is your happy path. Your not as happy path, which is still not as bad as it could possibly be. You get frisked and searched. Again, not as bad as it possibly could be. You wait in customs, you get your bag at your entry point, you have to go back through customs and so forth. So it's just a little bit more line standing for your not quite as happy path. So most of these are covered in the patterns we'll discuss. And the first one is the tag team. Now, all of these have like boring names, and all of these have like cool names I made up. Feel free to take them out and populate them into the universe. And no need to give me credit. But if I need a job, look me up. All right, so the first one is the tag team or the queue manager. Typically, a queue is going to look like this. And queue people who have worked with queues? All right, so you guys, hopefully I'll be able to tell you something. Who's not worked with queues? All right, so I'm going to talk to you. So essentially what you have is you have a queue worker and you've got your jobs queued up. So as they're queued up, you go through, you process one after another after another. Pretty much like standing in line at the grocery store. When you get up to the checkout line, they process your groceries and you're out the door. A typical airport scenario, what you've got is a series of connected lines, which you've got whatever hell you came from, and then whatever hell you're in, and then whatever hell you're going to next. That's what your current hell looks like. So they've got a manager up at the front, and you've got your queue, and the ones that are green are being processed, they're kind of happy. The ones that are yellow are getting kind of anxious. The ones that are red are late for their flights. So what you typically would do then is say, all right, I'm going to add more workers. So if I add a worker here in the green, then as it goes through, I add more workers in order to get the yellows to turn to green and the reds to turn to yellow and so forth. So as I add a worker, then more gets processed. I add another worker, when it turns red, then I get more processed until I have yellow, and I get rid of a worker, and then until I get green again, I get rid of both of them. So basically I'm calling them off break, and they come in and help, and then when I get down to the point where it's manageable, they go back on break. Everybody's on break all the time. So in a system design, looks very similar. I've got a queue manager, and I've got my queue workers that are designed to do the same thing. If my greens start to turn to yellow, then I add a new worker. As yellow starts to turn to red, I add a new worker, and then get rid of them as they go through, and it goes on to the next stage of work. And we'll talk about the math that's required for this. Now, one of the things that what essentially it looks like then is you just basically add queue workers ad infinitum until you get down to the capacity that you want. Number 2, open up another damn line. You guys have seen this before. You walk in, and a lot of times it's more for us. This is not bad. This is actually kind of good. But if you walk in and there's a huge line, but there's all that open space where they actually, if they hired more people or paid them better or didn't let them call in sick every day, then that could actually help you with your stuff. But this comes down to physical capacity. So in an airport, I've got physical capacity, and this is a TSA example. All those dark gray lines up there are just extra ways they can open up move the little velvet rope and let more people come through, assuming they have workers to actually take care of them. But in this situation, you've got your masses, you've got your pre-check workers and your frisk workers. And notice that the frisk worker jobs are a little bit longer because it takes longer to pat people down. So that's if you've got physical capacity. If you want to have more people work or more people go through, you just add them into those dark gray boxes up there, but you've got to have corresponding normal workers up here to handle them. So we can mimic that in the airport model by adding more queues and more corresponding workers, just like this. So I've got a queue worker to handle that queue, a queue worker to handle that queue, and a queue worker to handle that queue. The thing is, I've got to be able to balance the load. So what's one thing that you do when you got a long line and they open up a new one? What's the first thing that happens? They say, I can help, who's next? What do you do? Yeah, everybody looks around and goes, I don't see anybody moving. So somebody always takes the initiative and they jump in first. But you end up self-balancing, right? So you'll self-balance that load of jobs to do. And that's what you have to do the same thing here. If you start opening up new queues, then you've got to figure out how to balance those jobs out. Now, personally, I'd rather do this. This is one we talked about before, again, where we've got the previous feeder, the next feeder. I just add more workers. I keep the same line, however long it is, and I just add more workers to process those jobs quicker. Because one of the things that you also have in a situation, if you open up a new line in, say, a TSA line, and you've got the passports for your family, and they open up a new line, and your kids run off to the other line, where are they going to go? You got the passports. So you've got a dependency in between the actual people in the line in that situation. They can't move because you don't move. You kind of move as a group. If you have jobs, the same type of thing, if you've got a job dependent upon another job being done, you can't just start carving up your queues and adding more queues to it because now your jobs become disconnected. All right, so simple scaling. I told you to be math, and here's the math. This scenario, this is not compile. I made this language up. It's for illustration purposes only. Please don't try to build anything with it. But essentially what it's trying to show is I've got a maximum queue depth of 1,000. I've got a worker count of 1, and I've got a time in seconds that it takes to process is 1. For each job, it takes a second to process. And I've got a maximum time of 25 seconds. So nothing should be in the queue for more than 25 seconds. What do I have to do? So essentially, I come up with a formula. It's brilliant, absolute. I mean, look for it in all the mathematical literature coming out this next year. With my queue depth divided by the number of queue workers I have, or divided by the time, if it ends up being greater than the time allowed, then I'm going to hire a new worker. I'm going to create a new worker, exact replica of that one, and throw them out there and have them start depleting that queue. Now, when that calculation comes out to be less than the maximum time, I can start taking those workers away and just basically throw them back, put them on break, or decommission them. This is how you start getting in cloud development, where you've got the curve of the demand and the processing ability, that you have that elasticity curve. This is where it comes from. And some more pseudocode. So essentially, when I spawn one, they continue to work until they get told to stand down. And then when I want to riff one, I tell the worker to stand down, and they collect their paycheck and they go. And then this is Go code that basically says what I just said, but I wanted to show you that I actually do have the ability to do real code. And this one is just to make sure, the thing you have to make sure with this one is you want to make sure that the worker is finished with their task before you get rid of them. And this is a base level thing for all the patterns we talk about today. You can't get rid of a worker that's in the middle of a task. So if you're going to the grocery store and they've got halfway through your order, how much would you appreciate it if they sent that person on break? Probably not a lot. Okay, prioritization, the halves. This one is, okay, everybody put yourself in you're priority number 4. And this is a prioritized queue. And I think IBM does this. I think Microsoft's queues do this as well. And you can have a prioritized queue where basically you can say, if the job's prioritized as number 1, put it right at the front of the line. I have never, ever seen this in any kind of example in the real world anywhere, airports or otherwise, which is probably good. But essentially, you're the poor sap, that's the number 4, and if a new number 1 comes in behind you, they get moved to the front of the line. So when those 2s, 3s, and 4s get processed, it's hard to say. I don't like this pattern at all. So aside from reinsertions, which we'll talk about in a minute, I've never seen this anywhere, which is good, because if you did have that, this is what you would see. OH. Yeah. That still kills me that people claim that. Riots, yes, IO. So what we end up having is a different kind of prioritization, which I'll call 3A, how the other halves live. In this scenario, I've got random people coming out here from the left-hand side. This is your people milling around. They got their tickets. They got their boarding pass. They're just milling around before they get to security. Once you come into security, though, I can carve you up into a normal area, your pre-check, your frisk worker, and then eventually out to the gate. So essentially, then I have the ability to add new lines, but then prioritize you based upon some other type of arbitrary prioritization. Who are my TSA pre-check people? Oh, only a handful of you? Guys, $80, the best $80 you'll ever spend. If you spend more than a few hours a month in an airport, I would highly recommend it. But the TSA lets you get prioritized into this second one over here, and you're out the door. I mean, you've seen them. If you're not TSA, you've seen those jerks, right? They come in, and they go right up, and they don't have to take the shoes off, no belts off, no bags out of the, or laptops out of the bags. You hate those guys, right? The best way to beat them is to become one. I've only heard of one person being denied that nice benefit. Horrible story. The other way to queue is this is more of a segmentation than a prioritization, and you guys have seen this when you're getting on a plane, and I believe this is an example of like what American Airlines would work. So you've got your people that are already somewhat prioritized out here, they're random. When they come in, based upon where they are with their status, they get in first. So like your first class passenger would be up at the top. But in the queue world, what I essentially have here is I have a worker for each one of these things. I have a queue, a high priority queue, and a worker for that. A lower priority queue and a worker for that. So they each have their own ability to come in. Some of these would be processed simultaneously, but the 15 would be not near, it wouldn't go down to 15. It would have its own thing, it gets processed right away. Whatever gets thrown up there gets done. Then the arbitrary prioritization, or the every man for himself, this is the one where it's when you get on the plane. And this is where I talked about before how it was more important to do positioning yourself for gate insertion. And this is where your first class passenger, your diamond, platinum, your Windows people. Then you see up there the number 18 decided that they were gonna, hey, we're higher than where we should be, so they jumped in line because they're jerks and they're not checking their boarding pass. So this essentially what that happens is your prioritization based upon some sort of other criterion. This is Southwest, how they deal with it. More groups, so A group, B group, C group. When you do a system, same kind of thing. You have essentially a dedicated queue, a priority queue, a sub-priority queue, a lower priority, and you have one worker that essentially goes through and does them all. So this is the example, get a little bit ahead of myself. 15 will get done first, always. Whatever goes in that queue will get done before anything else. So if a number 45 comes through and goes up into that high priority queue, they'll get processed before all these other ones in here. We have a situation like this with a emergency helicopter company, where when they push in a button that says 911, we need a helicopter out to our hospital or location, then that essentially gets put at the top of all the other work that we have going on for queue processing. That gets put on top and gets handled first. And then all these will get handled once everything else becomes depleted. The reinsertion, which I alluded to a little bit before, or the, hey, can you let me cut, I had a thing. All right, so the only times I've ever seen line or signs that basically say don't cut in line are at amusement parks. So apparently it's a situation that with kids and whatnot, that they have a tendency to cut in line. Airports, I've never seen any activity like this where you jump in line and you're eaten or consumed by demons and so forth. That doesn't happen. But there is a situation though, if you go in and you have a problem with your process. You go in an airport, you have a problem with your ticket, it comes up, your flight's been canceled. All right, what are you gonna do? You look back and there's 45 people behind you and there's one worker up there. It's gonna take forever to get you done, right? So what they typically will do is have somebody else come up and help you. You step off to the side and they continue on the normal flow of stuff. So effectively what it does is you go from a ticket worker to a problem worker, and then once you get handled there, your baggage gets handled and all the other things that go on with regular processing. The thing comes in though is if you come in, say you have a problem with your payment. You come in and says, oh, I'm sorry, your card's been declined. I need to help the people behind you. Stand over here, and when you get done, come back over here and I'll finish you out. So you step over, they handle whatever you need to do. You give them a different credit card, give them cash, whatever. And they put you right back in as opposed to putting you back at the back of the line. That would be a reinsertion. In a system world, it's not really, in a queue world, I don't really do that as much as you would think. If I end up handling you for the queue worker saying I have a problem with you, I'll put you at the end of the problem line and you'll get solved, hopefully eventually. And when you get up there and you'll get solved, you may get put back onto my queue worker line to get rather processed. So say, for example, I've got a dollar figure that's out of whack or out of whatever tolerance I have for a piece of data coming through. Like I had a deposit for $10,001, which never happens. $10,001 essentially means I'm going to have to do some sort of extra processing with it. So if I want to go back and change that into two, 9,999 and then $1 or $2, then I can put that back, either handle them there or put them back in line to get them reprocessed from there. That's a bad example, but I think you guys know what I mean. And then from there, I have notifications and so forth. So essentially, it's just a way of me processing people through queues and handling the problems either directly or putting it back on. Queue processing, a lot of times, is a very lazy way to do development. It's also a very awesome way. So whenever I have a problem, I don't have to solve it there. I can just put it on a queue, a different kind of queue, like say a problem-solving queue, and let them deal with it. So if I've got a bad piece of data, for example, I can't find your ticket, I put it on another queue, and it goes through another process to be handled. And I just go on about my day processing the happy path stuff. Oh, let's see. In this example, just to show that the number one thing came through here, went through the queue worker, had a problem, and ended up being processed second because the number two process actually went through without problems. So it's one of those things where it doesn't guarantee the order that you're going to get processed in just because you came in first. And most queues, obviously all queues are defined to be first in, first out. Just because you're first doesn't necessarily mean you'll be first out of the processing gate. Excuse me. The metric mule. This is my favorite one. Essentially, in order to be able to do some of the scaling we talked about before with the highly complex math that we saw, I have to have numbers to put in all those variables. In order to have numbers to put in all those variables, I have to measure whatever I can. So in this case, we'll have to measure when something comes in, something goes out, how long it takes to do individual types of jobs and so forth, and I have to keep track of that. That helps me build my mathematical calculations. So the size of the payload, the number of transactions that go through, all these different types of things I can measure, response time, so forth. Now, who's ever been in an airport situation where you're in TSA and the TSA guy comes up to you and says, "How you doing?" And he reaches in his pocket, he pulls out something and says, "Hey, can you hold this for me?" All right, so if it's a TSA person, sure, you're going to hold it for him, right? But if it's like me, come up to you, it's like, "Hey, psst, buddy, can you hold this for me?" Yeah, it's not going to happen. So anyway, what happens was the TSA will go through, and they'll have a little ticket, and they'll give it to you. And they'll give it to random people throughout the process, and they'll have a time written on it. So they'll come up, they'll write a time on it, and they'll give it to you, and just say, just give it to the guy when you go through when you get back into the X-ray machine. Sure, no problem. And if you look at the back of the X-ray machine, they'll have something like this a lot of times in a more condensed format. This is a spreadsheet that I found on the internet. But essentially what it is times during the day and the various different terminals that they have, how long it's taking for people to get through the section. And it's just a metric or a very manual way for them to be able to determine how quickly they're getting people through, and if they need to have more workers at a certain time of day and let people go, schedule people off for certain parts of the day too. The nice thing about our job is I can measure everything. I don't have to give one person a ticket here, one person a ticket there, one person a ticket there. I mean, I could do that, but I can measure everything for pretty much no cost at all. So every single packet that comes through a queue, I'll measure, because that way it gives me a better idea for actually how long it takes to get through the process. And again, just your obligatory line of code. As I go through, where I'm measuring all my log entries, go through, I timestamp them in and out, so I know how long, when it goes in and when it actually gets written out to the database, how long it takes for it to do that. So I have an input stamp and an output stamp, and the JSON kind of looks like that. So it's just standard stuff you do when you put a procedure in. You're like, oh, I wonder how long it takes. Start, current system time at the top, system time at the end, subtract them, and there you go. Now, using the timing data, so if you remember, again, I know I showed it to you twice because it was so complex, you probably didn't catch it the first time. There's the same calculations that we used. I can now fill these values in automatically. So that t becomes a variable that grows and it goes down based upon what the actual numbers are, so how long a job goes through. So if I have, if I use airport vernacular still, a luggage job takes 4 minutes and a ticketing job takes 1 minute, I can vary the workers based upon the time for each of those individual types of jobs going through. And again, timestamps for starting and stopping. Lastly, the begetting. The you had one job, Phil. Anybody familiar with this meme? What other movie opens up today? That's like somewhat big. Not the one where Tony Stark dies. The Jurassic World, right? So if you guys have seen Phil Tippett, he was the dinosaur supervisor for the original Jurassic Park. He had one job, to supervise the dinosaurs, and they ate just about everybody. So obviously he failed very miserably at that. How that correlates to what we're doing here is I typically try to do queues that have one effective job. That's all they do. They do logging, they do error management, they do notification, they do email, they do push notifications. Whatever the case may be, I only want pretty much one kind of job going through it. They may have different characteristics of the job, so I don't have like thousands of queues everywhere. I still have to manage it, but at the same time, I want to be able to have a certain type of work that I know if I have a problem, I'm only having a problem with that type of work and not everything else. So one job, as much as possible. So in the situation though, when I go through and I grab a ticket, as soon as I get that ticket and I check in, all sorts of things happen. So I've got a piece of baggage going through, it's got its job. I've got a gate worker that's going to be looking for me to get on the plane at some point in time, before boarding time. I've got a security worker that knows I'm kind of milling around somewhere out there. So all these things now are in play that they're waiting for me to come through. So what happens is when by one transaction, by one operation, I beget a whole bunch of others. So as soon as I scan this, then all sorts of things just starts happening. So in the case of a system design, though, when my transaction goes through, I need to log it. If I have an error, I have to put an error out there for it, which if that error goes through and gets processed, that has to get logged. So it generates another entry. Notification for any kind of email that goes on, that happens too. And then also my metrics worker is happening. So I've seen one transaction, it's almost like a flower. A flower or atomic bomb explosion, just use whichever one you want. As one goes through, then all of a sudden you've got jobs that start looking like this. Each one of those will spawn other jobs that will go out like this. So I've seen one job actually have 25 different transactions get generated in a queue, which makes it's really cool because something happens, I give it to the notification guy, he handles it. I give it to the error person, they handle it. I give it to the log person, they handle it, which is great, but if you have a problem somewhere, you've got to debug all that too. So one transaction essentially generates dozens of other ones that go to the respective queues. And what the code would kind of look like with this. In this case, the telemetry is our metrics or our analysis piece. And then it goes to work queues and then error queues as well. So just one transaction would spawn potentially 3 or 4 more transactions. So my 7 in neat little summary form. And that's pretty much it. Anybody have any questions? Yes, ma'am. Oh, I'm sorry. Yes, sir.
So you identified that you're kind of adjusting the queues based on the average time that it takes to complete a job. In that case, how do you kind of account for outliers, in terms of say there's one job that ends up taking one or two longer than maybe throws off the average?
Yeah, that's a good question. It's one of those things where I typically, if it actually finishes, then it's going to skew the average either one way or the other way. If I get enough jobs going through, it depends how many outliers I have. If I have a lot of outliers, then it's definitely going to move it up. But if I have one outlier in the case of millions, it's probably not going to make that much of a difference to be material because by the time I figure out what to do with it, it's gone. And I've got another talk about the transient nature of data today where you need what you need when you need it, but after that, you don't care. And that would be one of those situations where if it doesn't impact, if it's just like a blip and maybe the lights flicker, people look around and by the time they can take another breath, everything's all back to normal. It just comes down to, is it more systemic where it happens all the time? And if you're, depending upon what you're doing with because you're gathering all this data, if you're putting it somewhere to where you can actually go back and do some kind of triage on it and say, all right, this particular job, we have, it ran like this and all of a sudden we had a spike. You could go out there and look at that particular job and say, all right, what would have caused that particular one to do it? But it's more of a postmortem as opposed to a real-time thing for it. If it became a problem, then you'd have to generate some sort of real-time solution for it. But unless that, it's fire, forget. Is that cool? Anybody else?
You mentioned how workers should never be retired if it's currently working on something.
Yep.
The same principle apply for queues. Like if you have 3 queues of the same priority, and you deem now you'll need 3, you only need 2 again. Do you shut it down and redisperse it down to 2, or do you really run its course until it's empty? What's the best practice?
It's like traffic would be on a road. I would probably let it run its course as opposed to stopping it and trying to figure out how to divert everybody. But at the same time, I'm blocking off the entry so no more traffic comes in. So it'll deplete itself after a while anyway. Anybody else? Yes, sir.
So you have a certain capacity of queues, you realize that you're getting overloaded, you use some time to So what the spin-up process of queue workers takes so long that it actually can still impact the time in queue, which for me, in my situation, that's a big deal. We got to keep our queue counts low. So,
Right.
are there any ways to compensate maybe for the time it would take to spin up?
The question was, is there a way to compensate for the time it takes to spin up a queue worker? I guess it depends on what your goal is. What I typically try to do is my queue workers are very single function in nature. So to spin one up hopefully takes no more than 5 seconds. That would be an outlier at that point. If it's one of those things where you have to create a whole new subsystem of stuff and libraries have to be compiled. If you're like say like a Docker, you're like bringing the initial thing in, it's having to do all the building at the same time. It just or spool up a new VM. If you're doing it that way, then it becomes a little more difficult to do. It just comes down to is the time that it takes to spin it up beneficial still. You can still process things with a queue as opposed to letting it ride for the regular queue. I mean, if your time is less, then it obviously still makes sense to do that. But I would probably look at redesigning it so it's more of a process-based as opposed to a VM-based. So if I need to have new ones, then I just spawn up new processes that are much, much quicker to do. But it also possibly requires you to redesign your application so that it's not doing as much and you've got little pieces of it. Because the problem ends up being is, and I've seen this like with end-of-day type processes, the whole thing doesn't need to be scaled. A lot of times it's just like this one piece in here that does. And if you decompose the work such that you can break off the individual applications or services such that they do that, or the processes that they do that, you can scale just the one that you need up and down. Because everything else just lives happy, for regular processing all the time. It's just that one little spiky thing that needs to be done. But you may not be in a situation where you can do that. But if VMs are hard to spin up in a time frame that you want. So containers is one of the things I use. Anybody else? Yes, sir.
I apologize if this has already been asked, but I can't really hear a lot of the questions.
Sorry.
For a lot of the prioritization, for the priority queues, there's a risk of starvation. Let's say that your priority queue is completely filled up almost all the time. I know that's a big case. But how do you go about handling starvation in the sense that nothing else gets done in the priority queue?
Is it just the one queue? Oh, that's right. The question was how do you handle starvation of a priority of queues, of all the other queues, if the priority is constantly sucking up all the resources? Is that accurate? Okay. Is it just you just have the one queue? Can you not have more queues, or is there a design issue there? The one I had up there was a model of RESQ. I don't know if you guys are familiar with RESQ. It's a Ruby-based queue that GitHub uses. And that's more of an order of precedence. So the first queue defined is the higher priority queue. And if you get things that are thrown in there, yes, you're going to starve your other queues because nothing else will happen. And it's one of the things why I usually do, like in that scenario, like system and log queues are at the end. But you can see those queues getting backed up because as all the high priority work, and even if it's not just like priority work, it's just work, your logging queues and your error processing queues could lag behind substantially because they just grow and grow and grow because we're being starved with that. That's that particular piece of software. In something like a RabbitMQ, I just have multiple queues and they all have the same priority at that point. It just comes down to which queue gets whatever transactions I have, and I have individual workers for each of those queues at that point. So that way, even if I got a high priority queue over here, which means I've given it like maybe more resources as far as memory goes or CPU percentage and so forth, it's getting done faster. I still have other queues that are attached to other processes that always get handled regardless. So it's a queue design issue more than anything else. And it's the whole thing, if everything's high priority, then nothing's high priority type thing. So it may be also a manner of just taking your work and carving it up. And because there's got to be something even within that that is lesser priority than the higher priority. And then you just have more queues to handle those. Yes, sir.
What's the pattern that you use to manage all the workers? So if you have a lot of servers and you have a lot of workers and their processes, it gets to be pretty hairy trying to manage those. Just keeping track of how many you have.
The question is, how do I handle scores of workers, scores of queues, scores of managers that all have the DevOps talk right before this one? It's probably something there because it becomes a visibility issue at that point. Is can I see all of that like on a dashboard type thing? It's a situation where it becomes more of what's the depth of them, and if I hate to say you're going to write something over the top of your queue management software because I'm not one for writing queues either. I go out and get a piece of software for it and I implement it. Then it comes down to the logical design I have for how the data gets into it and out of it and processed and so forth. To manage those, it's going to come down to does that software have a piece of software that can essentially manage the clusters of them like a RabbitMQ would, or do I have to write something special to do that when it becomes more of a DevOps problem where I have to keep track of all the queues, the depths of all of them, and set off alarms and alerts and so forth to do that. If I try to have my queue workers be smart based upon what's going through them, I can do that. What I usually have on if you have a cloud situation like AWS or Azure or something like that, Roku even, is if you put thresholds on there, then they'll tell you when your work is starting to go over whatever monetary threshold or number of CPUs threshold that you've got. And you'll have to then start looking to see if, all right, is it because I've got so much more traffic because I'm getting rich because all my stuff just got shown on the nightly news or whatever. If I've got that kind of problem, or if I've got a problem because I'm generating more errors than I normally do because of something else is down. So now all of this cluster is taking all the work of this other cluster too. It comes down to it depends on the queue software that you pick and what mechanisms they have, and if they don't have anything, then you end up writing something for it. Because all it ends up being is in some queue systems it's just a database, and you're looking at how many records does this database have, and it just processes them one after the other. So whatever you would typically have for like if you're using Nagios for example, just a little script that says how many rows in this table. If it gets to be over 1 million, then we got problems, type thing. So it's a non-answer, but it's essentially it depends on what queue you're using, what your thresholds are, and how much work you want it to do for you. Yes, sir.
Does priority ever change for like a unit of work for somebody who's in the queue?
The question was, does the priority ever change for something once it's already in the queue? If it does, it's hard to say how you would reach in there and actually grab it to change the priority because it's stuck in there somewhere and it won't be seen again until it actually gets processed by whatever job is going to do it. Now, what I have seen is something goes through in one priority, and based upon how it gets broken out from the sub-transaction. So like, for example, we have one where the helicopter client I mentioned is reporting vehicle position, and it's reporting status and so forth. And when it goes through and reports status, if the status is like you're arriving imminent, like you're within like a minute, 2 minutes from actually arriving at the location, then it breaks out some higher priority type pieces in there to make sure that it's being taken care of and acknowledged by the doctors and so forth. So once it goes through and you see that, then you can break them out at that point and then reprioritize the subcomponents of it and based upon where you put them. But once it's in there, it's in there for that particular package, typically.
Is it ever like based off of like how long you've been in the queue?
If it's based upon how long you've been in the queue, it could be, yeah. I mean, depending upon how you design your queues, like if you've got a bunch coming in and then you've got a relatively the same level, then you've got after that you've got higher priority and lower priority queues. It's like, okay, yeah, this one's been in for 10 minutes and we've got SLAs we need to meet. Then it goes into the high priority queue and all the rest of them can just get processed whenever based upon that time. Yeah, but it comes down to how you want to design your queues because that becomes an architecture all itself. Is almost like designing the roads the streets and roads in a town. How big you want your highways to be, where they're going to be, what kind of cars, no trucks allowed in this one, no bikes allowed in this one, type thing. Anybody else? All right, so for just so you know, I did not see the movie last night. So if Tony Stark does die, my bad. Thanks, everybody.